Hi everyone, and welcome to our video on graphing linear equations in standard form. So we've already tackled slope-intercept, endpoint slope. Today we tackle standard form. So let's just remind ourselves what standard form looks like. So the standard form of a linear equation is ax plus by equals C. And if you remember our little trick, it looks like Ax body cologne. Remember the A value must be positive. A must be positive, which if you look down here, all of our axes are positive. And the other stipulation was that A, B, and C may not be fractions. And if you look down here, no fractions. Perfect. Okay, so here's what we're going to do. Let's take a look at our three color-coded lines. We're going to start with purple, move to red, and finish with blue. So let's focus on purple. Now, we learned in a previous lesson that when an equation is in standard form, the easiest way to graph is to graph by the x and y intercepts, because standard form lends itself to finding those intercepts really easily, because it's really easy in standard form to just quickly let the y be 0 or let the x be 0. So method 1, I'll just call this method 1, to graph this standard form is to graph by the intercepts. Okay? Method 1 is to graph by the intercepts. So let's find both the y-intercept on this side, and we'll also find the x-intercept. Okay? So when we do a y-intercept, we let the x be 0. So it will look like this. 2 times 0 plus 3y equals 12. And when you take 2 times 0, that's 0. So this part just vanishes. And you're left with 3y equals 12. And you divide by 3. And so y is equal to 4. And so the ordered pair of this y-intercept is that when x was 0, the y was 4. So that's going to give us a point on our graph to plot. Now, the x-intercept, the exact opposite. We're going to let the y be 0. So 2x plus 3 times 0 equals 12. Again, the 3 times 0, poof, gone. That's 0. So I just have 2x equals 12. And when I divide by 2 on both sides, I get that x is 6. So when x is 6, remember what we did? The y was 0. So that gives me 2 points to plot. So if I plot 0, 4, 0, 4, which is the y-intercept, sits right there. And then 6, 0 sits on the x-axis over here. And bingo, there's my line. You just connect the dots and you've got yourself a graph. So that is one way to tackle graphing from standard form. Now, there is an alternative to this. I kind of ran out of room here on my paper, so I'm just going to add some paper here to the bottom so that I can continue on. You could go, if you're out of room also, you could go to the back of your paper. Or just get another piece of paper you can staple. But the other way you could do this, everyone, is to solve this literal equation. So say we take 2x plus 3y equals 12. Now remember when we did literal equations, they were fancy. I did the whole lesson in this accent because literal equations are quite fancy. And the reason is there's lots of variables in them. So say we want to solve this literal equation for y. Okay, I'll stop with the accent. Let's do that. So let's solve this equation for y equals. So let's first pick up the 2x. Let's move that to the other side. So we're going to minus 2x from both sides. These are going to cancel, and I'm going to have 3y equals. Now, I could write this as 12 minus 2x, but I'm not, because I know where we're headed. I'm going to actually put the x term first. So I'm going to write negative 2x plus 12. Negative 2x plus 12, because that's a positive 12 here. I can't combine them. They're not like. The 12 does not have an x with it. Okay, last step. Remember, I'm trying to get y by itself. I'm going to divide by 3. Everybody is going to get divided by 3. And so that gives me y equals negative 2 over 3x plus 12 divided by 3 is 4. Now look at that. We now have our standard form transformed into slope-intercept form. Y equals mx plus b. So the alternative here, we now know in this form that this is our slope, negative 2/3. And we know that b, which is our y-intercept, is 4 when x is 0. When x is 0, this vanishes and we're left with 4. So 0, 4. Now, let's go back to the graph. Now, we already have it graphed, right? We did the intercepts, but check it out. Let me kind of fold this here. If I bring this up, look how it matches. Look at this info. If you start your launching point from 0, 4, we already have that plotted, okay? Now, if my slope is negative 2/3, that means I'm going to come down to right 3. Boom. I land right there, which is already on that line. If I do it again, down to right 3, well, here I am on the x-intercept. So you see that whether you graph by the intercepts or by transformation to slope-intercept form, you are getting the same line. Okay, look at our next one in red. Let me change colors here. The next line is red. It says x minus 2y equals 4, clearly in Ax-By C form, standard form. Let's do method 1. Let's graph by the intercept. So method 1, graph by the intercepts, both x and y. So we'll come over here, do the y-intercept, and then we'll come over here and do the x. Have lots of practice with this. Okay, so y-intercept, you let the x be 0. So this will read 0 minus 2y equals 4. 0 vanishes. Negative 2y equals 4. Divide by negative 2. And y ends up being negative 2. So as an ordered pair, when x is 0, y is negative 2. Okay, the x-intercept. Let the y be 0. So x minus 2 times 0 equals 4. 2 times 0 vanishes, so x is equal to 4. When x is 4, y was 0. So let's plot these two intercepts, 1y, 1x. So 0, negative 2. 0, negative 2. 4, 0. Connect the dots. And we're finished. Intercepts are so easy when you're doing standard form. Okay, now the alternative. Let's do the alternative method here. Pull this back under here. Okay, so we've done it by intercepts. Now let's recopy x minus 2y equals 4, and let's solve the literal equation for y. So if we're going to solve for y, we're going to have to minus the x from both sides. So minus x, cancel, bring down the negative 2y, don't lose the negative, equals. Now remember, I want to put the x first. So negative x with a positive 4 on the back. Now, getting y by itself, divide everybody by negative 2. Cancel. Y equals. Now, a negative divided by a negative is a positive. And this x just has a little 1 in front of it. So we're going to call this positive 1/2 x. 4 divided by negative 2 is negative 2. Here we go. Slope-intercept form. So my slope looks like 1/2 from right here, mx. My b, which is my y-intercept, is 0, and it's b right back here, negative 2. So if I look at my graph now, let me bring this up. Bring this up. Okay, bring this down, bring this up. Let's look at the red line, and let's look at this graphical information. So it says we're supposed to be starting at 0, negative 2. Well, we are. And then it says that our slope is supposed to be 1/2. Let's see if it is. Up 1 over 2. Up 1 over 2. Up 1 over 2. Yes. So you see, you could graph it either way. Okay. And the last one, which is blue, says 5x plus y equals 2. Okay, so let's do method 1, graph by the intercepts. I'm not going to write that out again. You know what I'm doing. So let's do y-intercept here, x-intercept here. So let's let x be 0. 5 times 0 plus y equals 2. This vanishes, so y is 2. As an ordered pair, x is 0, y is 2. I'm getting pretty quick at this. X-intercept, let y be 0, so 5x plus 0 equals 2. That vanishes, so 5x equals 2. Divide, divide, and we have x equals 2/5. Not the prettiest. 2/5, 0. Now, this is a case where if one of your intercepts comes out not so nice, like if you say to yourself, listen, I'll graph 0, 2, but graphing 2/5, 0 isn't going to be as easy, this might be the perfect time to forego the intercepts and solve the literal equation for y and just graph it from slope-intercept form. So watch how easy this is. If we just take 5x plus y equals 2, and we minus, remember we're solving for y, so just minus the 5x, we will get y equals negative 5x plus 2. From here, you can easily graph this by our slope-intercept techniques. So we know that we start on the y-axis at 2, so 1, 2, and we come down 5, 1, 2, 3, 4, 5, and right 1. 1, 2, 3, 4, 5, and right 1. 1, 2, 3, 4, 5, and left 1. So if I draw that graph, if I connect those blue dots, what'll end up happening is we should see these intercepts. So 0, 2, are we good? Yep, 0, 2 is right there. And now remember 2/5, 0, I didn't want to plot that. Well, look where I am on the x-axis, right about there. And that looks reasonable. If you broke the region from 0 to 1 into 5 equal sections, this looks like it would be about 2/5, like 1/5, 2/5, 3/5, 4/5, 5/5. So 2/5 could be about right there. So there you have it, graphing linear equations in standard form. Thanks for watching.